A billion years of nothing much. Imagine the Earth. Not our Earth, but a stranger, more ancient version. A world with continents of a different shape, bathed in the light of a younger, fainter sun. A world with vast, shallow oceans, perhaps tinged with iron under a sky with a different hue. For billions of years, this was a microbial planet. Life existed, yes, it had for an immense stretch of time. It existed in the form of single-celled bacteria and archaea, invisible architects of the planet's chemistry. It existed as sprawling, slimy mats of cyanobacteria, photosynthesizing in the shallow waters, slowly, patiently, pumping a new toxic gas into the atmosphere. Oxygen. But it was a world devoid of true animal complexity. A world without bones, without shells, without teeth, without claws. A world without eyes that could truly see. If Earth's entire 4.5 billion year history were a 24-hour clock, this boring microbial era would take up the first 21 hours. A vast, quiet afternoon of prehistory. Then, in a geological instant, something extraordinary happened. Something so sudden, so radical, it has been called the Big Bang of biology. It was as if a cosmic switch had been flicked, and life on Earth exploded in a riot of new forms, a sudden unleashing of biological innovation that had never been seen before, and arguably has never been seen since. This is the story of that moment, when the silent microbial Earth suddenly roared to life with creatures so bizarre, so alien, they looked like they crawled straight out of a science fiction nightmare. This is the story of the Cambrian Explosion, the fossil record's greatest mystery. For Charles Darwin, it was more than a puzzle. It was a doubt, a shadow that loomed over his entire theory of evolution. His theory of natural selection was built on the idea of gradualism, slow, steady, incremental changes accumulating over vast eons of time. The tree of life should have countless deep branches showing the slow divergence of species. But the fossil record of the Cambrian period, roughly 541 million years ago, seemed to mock this idea. In the rock layers just before the Cambrian, fossils were scarce and simple. Then suddenly in the Cambrian strata, life appears in a dazzling, fully formed burst. There were trilobites, with their intricate, segmented bodies and the first complex eyes the world had ever seen. There were brachiopods, filter feeders already encased in sophisticated hinged shells. There were sponges, echinoderms, and the ancestors of mollusks. Darwin worried that this sudden appearance of complexity, without clear ancestors in the older rocks, could be used as a valid argument against his theory. Where were the transitional forms? Where were the saplings of this sudden forest? This mystery only deepened with the discovery of sites like the Burgess Shale in Canada. A fossil bed of such exquisite preservation that it captured not just shells and bones, but the soft tissues of the most alien creatures imaginable. Creatures that didn't fit into any known category. The Cambrian Explosion remains one of the most intensely studied and hotly debated periods in the history of life. It is the ultimate "where did they come from?" question. A world on the cusp. To understand the explosion, we must picture the world that preceded it, the late Ediacaran period. Life existed, but it was a strange, quiet, and alien gathering. It has been called the Ediacaran Garden. Imagine flat, quilted organisms like living air mattresses, absorbing nutrients directly from the water. Imagine stationary, frond-like creatures that looked like plants, but were in fact animals, filter feeding from the gentle currents. Imagine enigmatic disc-shaped life forms resting on the seabed. It was a world largely without movement, a world without predation. There were no teeth, no claws, no armor. The rules of the game were simple: absorb, filter, and survive. But this peaceful garden was being primed for a revolution. Oxygen levels in the ocean, thanks to billions of years of microbial work, were slowly rising. The chemistry of the seas was changing. The stage was being set for a new kind of actor to appear. The arms race begins. The fuse that lit the Cambrian Explosion is believed to be a single, terrifying innovation: predation. At some point, one creature evolved the ability to actively hunt, kill, and consume another creature. The moment this happened, the peaceful Ediacaran garden was shattered forever. It plunged the world into a biological arms race that has never stopped. Suddenly, there was an immense evolutionary pressure to innovate. Being passive was a death sentence. Predators evolved new weapons, grasping claws, sharp spines, and rudimentary jaws. They evolved the ability to move with purpose, to swim, to crawl, to hunt. And prey, in turn, evolved new defenses. The first mineralized shells and exoskeletons appeared, not for structure, but for armor. Creatures developed spines and spikes, making them a painful meal. They learned to burrow into the sediment, to hide, and they developed what might be the most important innovation of all: true, image-forming eyes. The ability to see the world in detail, to spot a predator approaching from a distance, changed everything. The world went from being a place of chemical gradients and shadows to a high-resolution landscape of hunters and hunted. This new, data-rich world fueled an explosion of new behaviors and new forms. It was a biological world war, and the arms race was producing monsters. Suddenly, monsters. The Cambrian seas were a gallery of nature's most surreal experiments. Creatures so bizarre they defy our modern understanding of biology. The apex predator was Anomalocaris, a creature up to a meter long, a giant for its time. It had two large spiked appendages in front of its mouth for grasping prey. Its mouth was a circular ring of sharp grinding plates, and it had huge, sophisticated compound eyes, perhaps the most advanced on the planet, giving it a decisive advantage. It was the T-Rex of the Cambrian seas. There was Opabinia, a smaller but even stranger creature. It had 5 eyes on stalks, giving it panoramic vision, and it had a long, flexible proboscis like a vacuum cleaner hose that ended in a grasping claw, which it likely used to snatch worms from their burrows. When this creature was first presented at a scientific conference, the audience burst into laughter. It seemed too ridiculous to be real. There was Hallucigenia, a testament to how alien this world was. A velvet worm-like creature with defensive spines on its back and delicate claw-tipped tentacles for legs. For decades, scientists reconstructed it upside down and backwards because it made more sense to their modern minds that the spines were legs. The reality was even stranger. And there were the trilobites. Not monstrous, but incredibly successful. They were arthropods, ancestors of insects and crustaceans. And they were covered in intricate armor, allowing them to roll up into a defensive ball. But their greatest innovation was their eyes, made not of protein but of calcite crystals, like a pair of living glasses. They were masterpieces of natural optics. The origin of everything, almost. The Cambrian Explosion wasn't just about creating strange monsters. It was the single most important creative event in the history of animal life. It was during this relatively short window of geological time that nearly every major animal body plan, or phylum, that exists today made its first appearance. The blueprint for arthropods with their exoskeletons and jointed legs appeared in the Cambrian. The blueprint for mollusks with their shells and muscular feet appeared in the Cambrian. The blueprint for echinoderms with their 5-fold symmetry appeared in the Cambrian. And most importantly for us, the blueprint for chordates, the group that includes all vertebrates with a backbone, appeared in the Cambrian. You, me, every bird, fish, reptile, and mammal on Earth can trace its fundamental body architecture back to a small, worm-like ancestor that swam in those chaotic, monster-filled seas. Remarkably, since the Cambrian, no new animal phyla have ever evolved. The fundamental ideas of animal design were all laid down in this one brief, spectacular creative frenzy. What triggered the Big Bang of biology? So what was the ultimate trigger? There was likely no single cause, but a perfect storm of converging factors. A new atmosphere. Rising oxygen levels after billions of years of microbial work finally crossed a critical threshold. This provided the high-octane fuel needed for larger bodies, active metabolisms, and the energy-intensive lifestyle of a predator. A new genetic toolkit. The evolution and diversification of Hox genes, the master architect genes that control an animal's body plan, gave evolution a powerful new control panel. A small tweak to a Hox gene could have dramatic effects, like adding a new body segment or sprouting a new pair of limbs, allowing for rapid experimentation. A new world. The end of the snowball Earth ice ages, which may have encased the entire planet, led to a massive release of minerals and nutrients into the warming oceans. This vast fertilization event created new ecological opportunities and the raw materials for building shells and skeletons. A new kind of life. The evolution of the first burrowing animals, so-called ecosystem engineers, fundamentally changed the seabed. Their burrowing oxygenated the sediment, recycled nutrients, and created entirely new habitats for other creatures to exploit. Predation, oxygen, genes, and a changing environment all came together. The fuse was lit. The world was ready to explode. a world we have lost. The Cambrian Explosion was a wild, untamed garden of evolutionary possibilities. Many of its most bizarre creations were evolutionary dead ends, experiments that were pruned away by natural selection in the millions of years that followed. But their legacy is our legacy. We are the distant descendants of the survivors of this tumultuous, creative, and violent period. Our eyes, our bones, our bilateral symmetry, our predatory instincts, all can be traced back to the innovations that first erupted in those ancient seas. The next time you look at an insect, a fish, or even your own reflection, remember the Cambrian Explosion. Remember a time when the Earth suddenly unleashed monsters, and in doing so laid the foundation for us all. Subscribe to Epoch Echoes, where the deep past reveals that life is not always a slow, gradual climb. Sometimes it's an explosion.